Assalamu alaikum. In this video, we are going to see what Goldbach's marginal conjecture is and how to verify it in MATLAB. Now, the theory states that any number greater than 5 can be, any number greater than 5 can be constructed by adding three prime numbers. So, for example, 6 can be constructed from adding 2 plus 2 plus 2. 7 can be constructed from 3 plus 2 plus 2, and so on. So, this conjecture is not yet proven, but it is verified up to a very large number. So, anyway, we'll see how to verify it in MATLAB. So, if I run this whole part and then try to explain, then I think it would be better. So first of all, I have taken the number for which I want to find the three prime numbers that can be added to construct that number. So first of all, I'm taking an array from 2 to 4 number less than that number. Now why 2 and 4 here? That's because the lowest prime number is 2. That's why there is no point starting from less than 2. And minus 4 means that if one of my prime number is 2, then the sum of the other two prime numbers can be at least 4. It cannot be less than 4. That's why here there is a minus 4. You can go up to n, or you can start less than 2. That won't change anything. Then we are finding the prime numbers from this array using this built-in isPrime function, which will return the return the index of which will actually, this function will return a logical array, and then from logical indexing we can find those numbers. Now this is a row matrix. Then we'll transpose it and make a column matrix, and then we'll take a 3D array. Now the reason why we're taking a 3D array, that's because we need to find three numbers using I believe you cannot do it using 2D arrays. Now in this whole process we're not going to use any loops. We'll use this 3D array to find the three numbers. So the size of this 3D array is going to be the size, it will differ depending on the size of this P matrix here. Here there is three columns in this matrix. That's why the size of this so the size of the C array will be 3 by 3 by 3. So 3 column, 3 row, and 3 page. The third dimension is called page here. Now we will also need another 3D array, but that array will have like one element in each page. So think of it that the P here is the length of the matrix. PT you can consider is the width, and this F matrix you can consider as the height. In this way we'll construct our the final 3D array. Now we'll use a technique called broadcasting here. So I think it would be hard to explain it here, but you can actually add this 4 matrix in this way, and using the technique broadcasting we'll get this H matrix. So what I have done is that this C was the empty, 0 3D array, and then we have added this P in each in each row, and then PT in each column, and F in each page. And after adding all of this, we'll get this H matrix. Now we can see that in this H matrix we have 10 here, 10 here, 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 and here. So there is 6, 10. Remember, 10 was the number that we have given as input. Now from this now 10, we need to find that which numbers are responsible for creating this 10 here. I mean, this 10 was created from the this matrix. Sorry, this yeah, this matrix. I mean, no, it's actually, this one is actually a 3D array. From this array, and this array. So we need to do some like back calculation or whatever. So first of all, we'll find the index of this 10 using this part, and then we will use this built-in function into sub. So this will return the subscript based on the index number, and we will store the value in this row, column, and page variable. And in this line, if we use this type of indexing from this part, we'll get our final output. So for this 10, we'll have this row, for this one we'll have this row, and so on. Now, I mean, this line can be explained, it's a bit hard to explain maybe. So for this 10, maybe this one will be first. For this one, we'll have like third row and second column and first page. So the value of row is 2, value of row is 3, column is 2, and page is 1. So if I put here 2, 1, I mean, yeah, 3, 3, 1, and 3, 2, and 1, PT 3, 2, 1, we'll get this 5, 3, 2 here. So in this way, the other numbers can be found out. Now we can see the numbers here are 5, 3, and 2. I mean, they are arranged in different orders here. Just, I mean, the numbers are same. So if we just randomly select a row and just show that row, we'll get our answer. So this is done in this whole part here. And then this line is not useful. I'm just checking if my the sum of the three numbers are equal to my original number, and there are three numbers in total. So yeah, in this way you can verify the Goldbach's marginal conjecture up to some certain digit, because this theory is not yet proven. So yeah, that was all, and thanks for watching.